We present Patcher for detecting, viewing, and patching web application vulnerabilities. Here is a very common vulnerability of the PHP script. The server receives the data from client by GET method and print out the data in the current page. It would possibly be an XSS vulnerability. Without filtering the user's input data, it may give hackers the opportunity to have malicious behavior by typing malicious input. To solve this problem, we can add a replace statement to modify the user input as a patch, so that it can prevent server from being damaged by the malicious input. But for users, it is difficult to know how and where to patch the vulnerabilities. We developed a patcher that is able to detect vulnerabilities and generate their patches automatically. Users first upload the file they want to check. The system will then first perform taint analysis to identify tainted sinks. A tainted sink is a sensitive function that may take values from user inputs. This is done by flow and data dependency analysis. For each tainted sink, we generate its conditional dependency graph accordingly and pass the conditional dependency graph to our string analyzer for further inspection. Then the system will perform four-path sensitivity string analysis on the conditional dependency graph, using automata to calculate all possible values of each sink while execution. If it includes an attack string, we report the sink as a vulnerability. For each vulnerability, we pass all reachable attack strings, characterized as an automaton, to vulnerability signature analysis. At this step, we use both forward and backward analysis with single-track and multi-track automata to generate all potential malicious inputs. Based on these vulnerability signatures, we generate effective patches for inputs that ensure removing all reachable attack strings and sinks. Finally, we store the report that summarizes the analysis and performance in the database, and users can access to the database to check the results. First, user has to log in. The user can upload the scripts or applications through the website. The input can be a simple script, a remote file, or a local file of the whole application. After uploading the file, the page will be navigated to a list which displays all the files that user has ever uploaded. This is the list of vulnerable files in the application. User can click to check detailed information of each file. The information includes source code, position of vulnerability, and the patch. If users click on the label of the vulnerability, the system will automatically find the positions and pass patch codes into source code. Now I'm going to introduce the app version of Patcher. After user logs in, app will list the file that user ever uploaded from the website, and user can click on one of the files. It will list information about total files, total vulnerability, and total analysis time. Below is the file list. Users can scroll to view the vulnerability of each file. One more thing about Patcher is the three-dimensional visualization of application status and vulnerabilities. We use beacons to represent the status of the whole application. Different color means different security level. Red ones are the dangerous files. Yellow ones are the files needed to be cautious. Green ones are the safe files. Then we can visualize the dependency graph. The white node represents the sink node. The red node represents the user input node. And user can click on the signature node to track the data flow. During the track of the data flow, user can check each node and its attribute. We try to build a service which integrates applications on different platforms, so we can display the data as a form of graph to enhance the usability and efficiency, and therefore improve users' comprehension. It is a piece of work integrated with security technology and digital art.